Hi, in this video, we will discuss case study 2. This video will covering chapter 4 about deformation in a transverse cross-section. The beam shown is made of a nylon for which the allowable stress is 24 MPa in tension and 30 MPa in compression. We need to determine the largest couple M that can be applied to the beam. To answer this kind of problem, we need to list all of the known given in the question. We have allowable tension at 24 MPa and we have allowable compression at 30 MPa. Then we have the dimension of the system. The strategy that can be used to solve this kind of problem is by a parallel axis theorem, where we divide the T-shaped cross-section into two different rectangles. By dividing the T-shaped cross-section, we can easily calculate the inertia for each partition. But since we need an inertia of the beam, we need to determine the centroid of the beam to apply the parallel axis theorem itself. We can determine the centroid of the beam by creating a table. The table is containing the area for each partition and the centroid for each partition. For the first partition, we have 600. It's from 40 mm times by 15. Then the centroid is calculated from the bottom part of the beam up to the centroid of the first partition, which is 22.5. Then for the second partition, we have 300 for the area and 7.5 as the centroid for the second partition. Then, by adding them up, we can obtain the centroid of the beam. It's 17.5 mm. From the centroid of the beam, we can determine the D1 and D2. The D1 is 5 mm, where D1 is a distance between the centroid of the first partition into the centroid of the beam, and the D2 is a distance from the centroid of the second partition into the centroid of the beam. After we obtain the centroid of the beam and the D1 and D2, we can calculate the inertia working on the beam. We calculate the inertia for the first partition by using this formula: 1 over 12 P1 H1 to the third plus A1 D1 square. By substituting the value into the formula, we can obtain the inertia for the first partition, which is 26.25 times 10 to the third millimeter to the fourth. Then we calculate the inertia for the second partition. By substituting the value into the formula, we can obtain the inertia for the second partition, which is 35.625 times 10 to the third millimeter to the fourth. We can add them up to find the inertia of the beam. The inertia will be 61.875 times 10 to the third millimeter to the fourth, or it will be equal to 61.875 times 10 to minus 9 meter to the fourth. After obtaining the inertia of the beam, we can use this formula to find the largest couple that can be applied in the beam. But we need to transform it first into this formula, where M will be equal to allowable stress times by inertia divided by the centroid. For the tension, we will have the allowable stress in tension times by the inertia and divided by the centroid. Then we substitute the value into the formula, and then we can obtain the maximum couple in tension. After that, we calculate for the compression. The allowable stress for the compression is times by the inertia and divided by the centroid of the beam. Then we substitute the value into the formula to obtain the largest couple that might be applied in the beam, which is 106.1 Newton meter. And then we compare the largest couple that can be applied in the beam, and then we choose the smaller couple that might be applied in the beam, because if we exceed that minimum value, the beam will be broke. So we choose 106.1 Newton meter as the largest couple that might be applied in the beam to avoid the failure in the beam.